In this video, we will try to understand the basics of search head clustering. Okay, so in next videos we will try to implement the different things needed to implement the search head clustering. Okay, but first we'll try to see what actually search head clustering is. Okay, and the different factors we need to consider when we try to deploy the search head clustering. Okay, then we'll try to deploy it. Now to do that, I actually created this particular diagram. Okay, so first we'll try to understand the architecture of search head clustering, then we'll see the different other considerations we need to do. Okay, now for that we'll see this particular diagram over here. Now if you see it over here, in search head clustering we have a list of search heads, right, which are basically connected to each other, and now among them there is one search head which basically act as a captain. Okay, now here the two important factors we need to consider. One is the search artifacts, which basically drives the replication factors. Okay, another is the runtime configurations and app configurations. Okay, because I want to segregate these two because there is a reason behind this. Now we will see when we will try to discuss this deployment considerations. We will see how they drive the search head clustering, but let us try to understand in terms of components. Okay, so in search head cluster we have a list of search heads which are basically connected to each other, and they share everything like the search artifacts as well as the runtime configurations and the app configuration. Now what search artifacts are? When a Splunk search runs, right, it creates a lot of files, like what are the indexers which basically participated in that search. Okay, what are the data it's generated, the metadata about the search, everything. And if I just go to this link, it is really important to understand what search artifact is. Okay, I'll be giving this link to my video description as well. Just check it out. Okay, now each search or alert you creates, alert you run creates a search artifact that must be saved to the disk. So what are the different kinds of file you create? Basically, if you see, the search artifacts are stored in Splunk home, var, run, Splunk dispatch directory. Okay, so here if you see, there are a lot of files it creates. What are the arguments, audited, buckets, events, generate, preview. So if we just want to know what is this different files means, you can check out these things as well. Okay, so there are a lot of files it creates when a Splunk search runs. So these are called together search artifacts. Okay, and if I want to segregate between, so if I just create a notepad, go there. So we have two things. One is our search artifacts. Okay, another is our runtime configs and other app configs. Okay, now these are like, if you just create a new saved search, new saved search or alerts or dashboard. Okay, so these things also get replicated between these searches, because for an end user, he or she can log into any searches and still able to run the search. That means for end users there should not be any different layer, because here if you see it, if this all of these searches are replicating each other objects, that means if a user log into this search it or this search it, for them it is not, there is no difference over there. Okay, so that's the idea behind the search head cluster, because one thing is, it is a high availability. That means if one search head gone, then we still have other search head which can act as a working search head for the end users. Okay, now for that region itself, we generally have a load balancer between the users and the search heads. Okay, this is an optional component, but this is good to have, because in that case load balancer will automatically redirect the user to the corresponding, redirect the load, basically the user request to the corresponding search heads here. Okay, now in a search head cluster, two things is very important. One is a captain, okay, and another is a deployer. Okay, now what is captain? Now a captain is also a search head, but apart from its normal searching jobs, it has another additional responsibility to basically sync the other cluster members. Okay, so to basically send the other datas, like this kind of artifacts or other configurations files to this cluster members. So this is also another important role of the captain. Now this captain is also called a dynamic captain, because if the captain goes down, there is another search head which will take the role of this captain. Okay, but then the captain election happens by through a democratic rule, so which we will be seeing it in future videos as well. Okay, how the captain election happens, but it happens through a predefined democratic rule only. That means each and every search head participate in voting to elect that captain. Okay, so captain is used for that one, and the deployer is mainly used to deploy apps and configurations files. Generally, if you create user apps and configurations files, you need to have a deployer to deploy all those apps into all of these searches. Okay, because that will not be automatically deployed by Splunk. Okay, that thing you have to remember, that one. Okay, and now each and every search head then communicates with the search peers or indexers to run the searches. Okay, so this is the overall architecture level details of the search head clustering. Okay, now we'll go back to our diagram and see the benefits of search head clustering. So as I said, the main benefits is it is a horizontal scaling. That means if you have more ad hoc searches or scheduled searches running in your system, and you have more users coming to your system, you definitely need to have a search head cluster to support them, because that much of load, right? Because a single Splunk instance may not be able to cope up with that particular load. High availability, as I said, if one search head goes down, another search head can take its place, and still the searches can run on top of these indexers. And because of the same reason, there is no single point of failure over here, right? So we talk about the benefits. Let's talk about the deployment considerations here. Okay, if you want to deploy search head, there's a lot of factors you need to consider. Okay, the first thing is the system requirement. Okay, now this is really important one, because now if I just see the system requirements here, each of the search head member must run on its own machine or virtual machine. We have to make sure about that one. Okay, and all the machines must run on same operating system. This is really important factor over there. You cannot have a search head cluster where one search head is running on Linux and another search head is running on Windows. You cannot have that. Okay, and also all the members must run on the same version of the Splunk Enterprise. That we need to make sure. Okay, all members must be connected over a high-speed network. That's true, because search head cluster, search members are always is talking to each other. There are a lot of communication happens between the search head cluster members basically, so that all the configurations file or search artifacts related stuff can be in sync in all the members, right? For high availability search, you must deploy at least 3 members. That means it's always good to have better idea. It's good idea that you need to have at least 3 search head members in a search head cluster. Okay, so we talked about system requirements. Now this is the replication factor. This is the most important factor over here. Now let us understand what replication factor is. Okay, now if you remember, just few minutes back I talked about search artifacts, right? And these are the search, when a Splunk search runs, these are the files it generates, right? Which basically stores the information, the various kinds of information about the search that it runs, right? Now this search artifacts is basically drives the replication factor. Now when we talk about Splunk search head cluster, right, So, and it's specifically true for safe searches and alerts, okay, those kind of searches, because those safe searches outputs needs to be sync with all the clustered members as well, okay. So for that reason, in whole searched cluster we keep a copy of this search artifacts, okay. That means we need to maintain a copy of these search artifacts accessible to the whole cluster environment, right? Now how many copies we will be, the number of copies we store in the whole system, okay, number of copies of search artifacts is the replication factor, okay, replication factor. Now this does not mean like does not equals to the number of cluster member we have, okay. This is equals to the number of search artifacts. That means that the backup of this artifact directory, okay, we are saving in the whole cluster member. That means we may have 50 members in our cluster, okay, see 50 members in our cluster, but we can set the replication factor to 3, okay, 3 replication factor. That means we are saving this search artifacts copy, three copy of this search artifacts, and now this could be saved in anywhere in the cluster member, okay, but only maximum of 3 replication factor, 3 copies of search artifacts will be storing in our system, okay. So that is the replication factor, okay. Now other configurations like this runtime configurations and app configurations anyway will be available to all 50 members. That means this will be synced 50 times, okay, but not this one, the search artifacts, okay. So if I just go back to our diagram over here, the replication factor determines the number of copies of each search artifact or the search result that the cluster maintains, okay. Now replication occurs only for artifacts from scheduled safe searches, okay, this is important. Now the search artifacts are created for ad hoc searches as well as scheduled searches as well, okay, but in clustered environment we only replicates the scheduled safe search artifacts, okay, not the ad hoc or the real-time search artifacts, okay. Now that means if I just go back over here to the notepad again, if I have three copies of search artifacts in our clustered environment, right? Now that means there are 3 members. It can be dynamically chosen or randomly chosen where we are saving those artifacts, right? And now let's say among these 3 members 1 member go down, okay. So that means 1 member down. That means we have now, so if I just go to the flow, 1 member down, okay. So that means we still have 2 members which we still have this search artifact copy, right? That means they will still be able to answer the queries from the end users, right? Now let's say another member goes down, okay. That means I have now another down. That means I have now one member which is still capable of responding to the end user search request, right? Now if this member is going down, that means this cluster will not be functioning at all, because there is no copy of the search artifacts which it requires to responding to the user searches, right? So that means a cluster can tolerate maximum of the number of replication factor -1. That means till 2 members it was fine, but when it is 3 members down, the cluster will not be functioning at all. That means here, this is the only part I have written it over here. The cluster can tolerate failure of replication factor -1 members without losing any search artifacts, okay. So this is the important stuff. The default value of the replication factor is 3. I think this is more than sufficient, but if we require it, there is a configuration as well, which we'll be discussing in future videos to how to set it up, okay. That can be done as well. Now the replication factor determines only the number of copies of the search artifacts that cluster maintains. It does not affect the replication of the runtime configuration changes such as new safe searches. This is what I have told over here as well, right? So there is a big difference between the replication factor and the replication of other runtime configurations. Okay, so hopefully we got a fair idea about what replication is. Now let's move on to the other configurations and search other configuration apart from the search artifacts. Now the cluster also requires all the members share the same set of configurations, because for an end user, if I just open the documentation, he or she can log into any searches, right? That means if you're creating a dashboard over here, this dashboard should be accessible here as well, so that when end user will log into this search, he can see that this particular dashboard, right? So that's the important consideration we have to do. So for runtime updates to knowledge objects, such as updates to dashboards or reports, the cluster replicates the configurations automatically to all members. That means the knowledge object replication happens automatically. But if you have some user defined apps or some other configurations, the user must push configuration through the cluster member called deployer. So here the concept of deployer coming into picture. So if I just tally it, the deployer is always outside of the cluster environment. We have to remember that one. Okay, this is not a part of cluster. Okay, its job is just to push those user defined apps and configurations to the cluster environment. Okay, now let's talk something about the deployer. Now a deployer is a separate Splunk instance. Generally it's a separate Splunk instance. What it does, it basically distributes the apps and other configurations to the cluster members, right? Now, as I said, like deployer can be a separate instance, but if you have a deployment server with deployment clients less than 50, you can integrate these two as well, both the deployer and the deployment server. Similarly, the deployer can be a part of index cluster master node as well. If you cannot afford a separate instance for the deployer, it can be with the monitoring console, license master, search cluster. License master only. Now it can only service a single search cluster. Now there is a possible that like you can have multiple search cluster as well. Okay, that means in that case, generally Splunk recommends that you have different deployers for different searches. Okay, until and unless you are basically deploying same configurations to all the search clusters. Okay, in that case maybe you can use a single deployer. The deployer uses the security key to authenticate the communication with the cluster members. Okay, we'll see how to set this one as well. Okay, now if you have multiple clusters, you must use a separate deployer for each cluster, as I said. But until and unless you are deploying the same configurations, you can, in that case, you can use a single deployer as well. Okay, now the next important stuff is the cluster members. As we know, this is the most important stuff. Basically, this is the search heads basically inside the cluster, which each and every search head we call as cluster member. So it's better to use a new instance always, because the process of adding an instance to a search head cluster overrides any configurations or app currently resident on that instance. So if you are trying to add a particular already existing instance to a search cluster, there are a lot of overheads over there. You need to remember those things, those steps as well. I'll try to see if I can make a video for that one as well. Okay, and this is the most important stuff, is you must change the admin password on each instance, otherwise it will not work. The CLI commands that you use to configure the cluster will not operate on instances with default password. You have to remember that one. This is very important. Anyway, in normal production scenario, we generally do it, but I just mention it over here. Okay, now let's talk something about the cluster captain. So it coordinates the job and replication activities among all the members, as I said, apart from its regular search like responsibilities. Okay, so we mostly talk about the different components and the different deployment considerations we need to do to create a search cluster, right? Now, after you create the search cluster, this is the post deployment consideration we have to do, is as very obvious that each and every search will be communicating with these indexers, right? this indexer could be a separate indexers, or it could be a indexer cluster as well. Okay, we will not be concentrating on this part. We will be mainly concentrating on this part, the search head cluster. Okay, that means there is a connection has to be done, okay, for that one. So that is the thing I have given it over here. Connect the search head cluster with the search peers. Then you have to add users, install the load balancer. This is an optional step. Okay, so that means if you need to have a load balancer between the user and the search head cluster, you need to do that one, and then use the deployer to distribute the apps and configuration update to the search heads. Okay, this is the deployer which will be updating this one. So hopefully you got a fair idea about how we should approach this configuration of the search head cluster. In the next video we'll talk about first how to set up the deployer. Okay, then we will see how to set up all these different search heads to communicate with each other to form a search head cluster. Okay, see you in next video.